Modern muscle cars have advanced to the point where they can now compete with supercars in terms of performance. The speed, agility, and power of today's muscle cars are comparable to the best because of developments in technology, materials, and design. In this video, we will highlight 7 key factors that have helped them achieve this remarkable feat. Number 7. Advancements in engine technology. Although the raw engine power of muscle cars has always been their defining characteristic, recent developments in engine technology have made them extraordinarily fast by today's standards. Large displacement engines, such as the iconic 426 Hemi V8, have historically been used by muscle cars to provide a considerable amount of horsepower and torque. But with the advent of contemporary technology, these engines are now more powerful and efficient. Nowadays, supercharged or turbocharged V8 engines are used by automakers like Dodge, Ford, and Chevrolet to increase horsepower without enlarging their engines. For instance, the 6.2-liter supercharged V8 engine in the Dodge Challenger SRT Hellcat produces 707 horsepower, while the SRT Demon produces 840 horsepower. Furthermore, advancements like intercooling systems, variable valve timing, and direct fuel injection enhance engine performance, enabling these vehicles to accelerate more quickly and attain greater speeds. In terms of sheer performance capabilities, current muscle cars are now on par with supercars because of this significant increase in engine power and performance. Number 6. Improved aerodynamics. Early muscle vehicles were characterized by their upright, boxy shapes that weren't very aerodynamic despite being outwardly aggressive. The car's top speeds and fuel economy were frequently constrained by this design's poor efficiency. However, manufacturers began to focus considerably more on aerodynamic design as muscle cars advanced. With an emphasis on lowering drag and enhancing high-speed stability, modern muscle cars are more streamlined and streamlined. To improve downforce and decrease drag, the Ford Mustang Shelby GT500, for instance, has an aggressive rear diffuser, an active rear spoiler, and a sculpted front end. Muscle cars are now comparable with supercars in terms of performance thanks to these aerodynamic modifications, which also help the vehicle maintain stability at high speeds and enhance turning abilities. Performance optimization has been improved with the advent of active aerodynamics, in which parts such as flaps and spoilers change in response to the vehicle's speed. Muscle cars may now compete with high-performance supercars because they are more stable and efficient, allowing them to reach higher top speeds. Number 5. Sophisticated suspension systems. Older muscle cars' suspension systems, which were frequently built more for straight-line acceleration than handling, were one of their main disadvantages. The end effect was a vehicle that could accelerate rapidly, but found it difficult to keep control when navigating sharp turns at high speeds. However, the suspension systems of contemporary muscle vehicles have seen significant advancements, integrating technology that improves comfort and handling. For instance, the advanced magnetic ride control suspension system of the Chevrolet Camaro ZL. One uses magneto-rheological fluid in the shocks to modify the damping rates in real time. This makes it possible for the vehicle to modify the suspension firmness for various driving situations, guaranteeing better handling and a more comfortable ride at both high and low speeds. Furthermore, a lot of muscle cars now have independent rear suspension, which improves handling and control, especially in tight spaces. IRS improves road grip by lowering rear axle hop, a typical problem with solid axles. Modern muscle cars are getting closer to supercar handling characteristics by implementing cutting-edge suspension technology, which allows them to corner precisely and maintain stability at high speeds. Number 4. Transmission and gearbox improvements. Muscle vehicles have also achieved great advancements in gearbox technology. Early automatic transmissions or manual gearboxes, which were less sensitive and slower to shift than contemporary systems, were frequently seen in vintage muscle cars. It has changed the game since dual clutch transmissions were introduced. A DCT improves acceleration times and speeds up gear changes by enabling quicker, more effective shifting. The Ford Mustang Shelby GT500, for instance, has a 7-speed dual-clutch gearbox that enables smooth, quick gear changes and greatly enhances performance. Additionally, sophisticated launch control systems that maximize power delivery during acceleration have been integrated into muscle vehicles. Launch control minimizes tire spin and maximizes grip to make sure the vehicle accelerates as fast as feasible from a stop. With this technology, which has been a mainstay of supercars for years, current muscle cars can sometimes reach speeds of 0 to 60 miles per hour in less than 3 seconds. Muscle vehicles may now accelerate more smoothly and quickly than supercars, thanks to the adoption of these cutting-edge gearbox technologies. Number 3. Lightweight materials and construction. A car's performance is directly impacted by its weight, and muscle cars have made great progress in lowering weight without compromising structural soundness. Because steel and other conventional materials were frequently used in their construction, muscle cars were historically heavy. To cut weight and boost performance, contemporary muscle cars have adopted lightweight materials like magnesium, carbon fiber, and aluminum. The aluminum engine block of the Ford Shelby GT500, for example, helps to lighten the vehicle while preserving engine power. In order to further reduce weight and improve aerodynamics, carbon fiber components are also utilized in elements like the hood and rear spoiler. Because the weight of the car lessens the strain on the suspension and brake systems, lightweight materials not only increase acceleration, but also enhance handling and braking performance. When competing with the handling and agility of supercars, muscle cars need to be more responsive and nimble, which is made possible by these structural advances. With the performance characteristics of a supercar, a lighter muscle car can accelerate faster, round corners more precisely, and stop faster. Number 2. Better tires and braking systems. Muscle cars' overall performance is greatly influenced by their tires and brakes. The tires and braking systems of muscle cars in the past were frequently unable to withstand the tremendous power produced by the engines. Nonetheless, modern muscle vehicles are outfitted with cutting-edge braking systems and high-performance tires, guaranteeing that they can manage the rapid acceleration and high speeds that come with contemporary performance. Tires from companies like Michelin and Pirelli, which are made especially to offer the most grip possible on the road or on the racecourse, are found on a lot of contemporary muscle cars. The car can move rapidly without losing grip because to these tires' ability to withstand the tremendous torque and power produced by high horsepower engines. Furthermore, sophisticated braking systems like carbon ceramic brakes, which are lighter and better at dissipating heat than conventional steel brakes, are now standard on muscle vehicles. Muscle cars are safer and more capable on the track thanks to these high-performance brakes, which enable them to stop from high speeds faster. Muscle cars can now meet the demands of high-speed driving thanks to advancements in tire and brake technology, putting them on par with supercars in terms of stopping power and cornering abilities. Number 1. Track-ready tech and performance tuners. Modern muscle cars are more versatile and capable in high-performance driving scenarios thanks to a variety of track-ready technologies. Many contemporary muscle vehicles come equipped with basic features like traction control systems, launch control, and changeable driving modes. For example, launch control makes ensuring the automobile starts as effectively as possible by modifying the engine's power output to maximize grip and avoid wheel spin. Previously only found in supercars, this technology is now commonplace in muscle cars, like the Dodge Challenger SRT Demon, which uses launch control to help reach its incredible 2.3-second 0 to 60 miles per hour performance. Many muscle vehicles now have adaptive driving modes in addition to launch control, enabling drivers to modify the vehicle's settings for various road conditions. The Chevrolet Camaro ZL1, for instance, has several engine, suspension, and steering modes that let the vehicle be tuned for either comfort or fast driving. With aftermarket modifications that can boost horsepower, enhance handling, and optimize other areas of the car's performance, performance tuners also contribute to the development of muscle cars. This degree of personalization makes it possible to modify muscle cars to perform well on track days, closing the gap between street cars and the track-ready vehicles that supercars have always been. These changes have made muscle cars not only fast but also incredibly capable, allowing them to compete with the best supercars on the market. Thanks for watching our video, and don't forget to subscribe.